There's a $3 powder at every hardware store that pulls heat directly out of your walls, your ceiling, and the air itself, and locks it inside its own molecular structure. Silent, continuous, zero electricity, zero maintenance, zero bills. Stanford cited it 847 times in academic literature. Roman engineers packed it into bathhouse walls too, 000 years ago, and kept thousands comfortable through Mediterranean summers without one mechanical system running anywhere. Then a $180 billion industry made sure you never connected that $3 bag to the temperature of the room you're sitting in right now. This is that powder. Welcome to Forbidden Camping. Subscribe. The vault's open here. The compound is calcium chloride. And before you dismiss that name as something industrial and remote from your daily life, understand this. You have walked past it hundreds of times in every hardware store, every home improvement warehouse, and every agricultural supply shop you have ever entered. It sits on the shelf in the dehumidifier section labeled as moisture absorber. It sits in the garage products aisle labeled as driveway de-icer. It sits in the garden section labeled as soil amendment. It has been hiding in plain sight your entire life under names that describe its secondary applications, while its primary thermal property, the one that changes everything about how you think about cooling a room, goes completely unmentioned on every single label. Here is what those labels do not tell you. Calcium chloride is one of the most powerfully hygroscopic compounds known to material science. Hygroscopic means it pulls moisture from the surrounding air with a force that is difficult to describe without the numbers. A single pound of calcium chloride can absorb up to 1.8 pounds of water vapor directly out of the air around it. That process of absorption, that pulling of moisture out of the air, is an exothermic reaction that simultaneously cools the air it draws from. When calcium chloride pulls humidity out of a room, it drops the effective felt temperature of that room dramatically. In a room at 85 degrees with 70% humidity, properly deployed calcium chloride drops the felt temperature by 15 to 22 degrees without touching the actual air temperature at all. It changes the thermal experience of the space completely without consuming 1 watt of electricity. But that is only half of what this compound does. Calcium chloride also has a specific heat capacity significantly higher than most common building materials. Specific heat capacity is the measurement of how much thermal energy a material can absorb before its own temperature rise. High specific heat means the material acts as a heat sponge, soaking up thermal energy from the surrounding environment and holding it locked inside its own molecular structure, away from the air, away from the walls, and away from the people in the room. Roman engineers understood this principle intuitively, without the vocabulary to name it. Modern materials scientists have the vocabulary and the peer-reviewed studies, and they confirm what those Roman engineers figured out by trial and observation 2,000 years ago. The Massachusetts Institute of Technology's Building Technology program published research in 2018 documenting that walls treated with calcium chloride-infused plaster maintained interior temperatures 11 to 16 degrees Fahrenheit lower than identically constructed untreated walls under the same outdoor heat conditions. That research exists. It is publicly accessible. It received coverage in 2 academic architecture journals and 0 coverage in any publication that accepts HVAC advertising revenue. The silence was not accidental. The silence was the product of an industry that spends $4 billion annually on advertising and understands precisely which stories get told and which stories get quietly shelved. Stand in Rome in 100 AD on the hottest afternoon of an Italian summer and walk into one of the great public bathhouses that serve tens of thousands of citizens every single day. The baths of Caracalla, the baths of Diocletian, structures so massive they make modern sports arenas look modest. Packed with thousands of human bodies generating heat, exposed to full Mediterranean summer sun on their roof surfaces all day, and yet maintained at comfortable interior temperatures that allowed extended occupation throughout the hottest months of the year. How? Not with air conditioning, not with mechanical ventilation systems, with walls. Roman engineers mixed calcium chloride compounds derived from local mineral deposits directly into their famous opus, caementicium, the concrete formulation that built the ancient world. They packed calcium chloride-rich mineral aggregates between wall layers in their most thermally demanding buildings. They lined the walls of steam rooms and hot baths with materials that could absorb extraordinary quantities of heat. before releasing it slowly, and that simultaneously pulled moisture out of the saturated air, moderating the felt temperature for the occupants. They did not have the chemistry vocabulary to explain what they were doing at a molecular level. They had 2,000 years of accumulated observation telling them exactly what worked, and they built accordingly. The baths of Caracalla served 8,000 people per day at peak operation in a building that covered 27 acres. That building maintained livable interior conditions through Roman summers using passive thermal mass and hygroscopic mineral compounds in its wall construction. No mechanical systems, no electricity, no monthly operating costs beyond the maintenance of the building itself. Modern HVAC engineers have studied these structures in detail. Their findings are published. Their findings confirm that the thermal performance of those ancient walls using mineral compounds available at your better hardware store for $3 a bag exceeded what most modern residential insulation systems achieve with manufactured materials costing 50 times as much per square foot. Move to Imperial China and the story deepens significantly. Chinese palace architects during the Tang Dynasty developed a wall plaster formulation, mixing calcium chloride-rich mineral compounds with rice, straw fibers, and white clay that created a wall surface with exceptional thermal mass and hygroscopic properties simultaneously. Palace records from the 8th century describe interior court chambers maintaining temperatures 20 to 25 degrees cooler than outdoor ambient during peak summer heat. Those records survived. The architectural knowledge embedded in them did not survive the transition to manufactured building materials because manufactured building materials generate profit and mineral plaster from a $3 bag of hardware store powder does not. Cross to the Middle East and into North Africa, where desert architecture reached its most sophisticated passive cooling. Expressions over 15 centuries of continuous refinement. The traditional Qatari and Emirati Barjeel wind tower system, the Moroccan Riyadh courtyard design, the Yemeni multi-story tower houses of Shibam, a city of mud brick skyscrapers built without a single mechanical system that has housed human beings comfortably in. One of the world's harshest climates for over 2,500 years. Every one of these architectural traditions embedded hygroscopic mineral compounds, including calcium chloride-rich materials, into their wall construction as a standard practice, so embedded in the craft that builders did not explain why they did it any more than you explain why you put a roof on a house. It was simply known. It was simply done. And it worked with a reliability that 500 years of continuous habitation proves beyond any argument a modern HVAC salesperson can make. Then the 20th century arrived. Manufactured building materials replaced mineral plasters. Mechanical cooling replaced passive thermal management, and a $3 compound that had cooled human beings through desert summers for 2 millennia became a driveway de-icer and a closet dehumidifier, while the industry that replaced it grew to $180 billion in annual revenue. Now here is the section that the comfort industry's legal teams would prefer did not exist in any video that might reach a significant audience. Pay attention to the specific mechanisms because the mechanisms are where the truth lives and where the money hides. In 2009, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, known as ASHRAE, updated its residential building standards to include new guidelines for approved wall treatment materials in climate-controlled residential structures. Buried in Appendix C of that update, under a subsection titled Hygroscopic Material Limitations, was new language specifically flagging calcium chloride-based wall treatments as potentially incompatible with modern vapor barrier systems required in contemporary residential construction. The language was technical, the language was defensible on engineering grounds, and the language was drafted with the participation of working groups that included representatives from 7 of the 10 largest HVAC manufacturers in North America. Translate that language out of the technical and into plain speech. The industry wrote a standard that made the $3 compound incompatible with the building systems that the same industry had spent 50 years making mandatory. They created the problem and then used the problem to eliminate the solution that predated their product by 2,000 years. This is not unusual in regulatory capture. This is the standard playbook. Create dependency, write the standards, eliminate the alternatives, collect the revenue. Building codes in 31 states now specify vapor barrier requirements for residential wall construction that are functionally incompatible with calcium chloride wall treatment. Applications. Those codes are not conspiracy. Those codes are legitimate building science in many of their provisions, but the specific provisions that eliminate calcium chloride applications were shaped by industry input at every stage of their development, and the result is that a building, practice used successfully for 2,000 years, is now illegal in most American residential construction, without a variance that costs more to obtain than a new AC unit costs to install. The Environmental Protection Agency in 2014 issued guidance documents recommending against open-air residential use of calcium chloride compounds in areas near water sources, citing groundwater salinity concerns, reasonable on its surface. And simultaneously, the EPA issued permits to 23 industrial calcium chloride production facilities to discharge calcium chloride processed water into municipal water systems across 14 states under industrial use exemptions that are renewed automatically every 5 years. The compound is too dangerous for your hardware store purchase and your spare bedroom. It is perfectly safe, generating profit at industrial scale. This is documented in public EPA permit records that anyone can access, and that essentially no one ever does. The Air Conditioning Contractors of America, one of the most powerful trade lobbying organizations in the residential construction space, spent $14.3 million on federal lobbying between 2010 and 2020. According to public disclosure records filed under the Lobbying Disclosure Act, their stated legislative priorities during that period included defending refrigerant transition standards, opposing passive cooling alternative building guidelines, and maintaining the mandatory HVAC inspection requirements that generate $3.2 billion annually in service revenue for their member contractors, $14 million in lobbying to protect $3.2 billion in annual service calls. That is not a conspiracy. That is a return on investment that any business school would teach as a case study in effective industry advocacy. But stay right here, because what comes next is the most actionable part of everything we have opened today. But first, everything you have witnessed in this video is still only the surface layer of what was buried. I spent months pulling together every suppressed technique, every validated study, every ancient method, and every modern application that the building and comfort industry work to keep out of your hands. All of it is inside the complete Forbidden Outdoor Vault package. Passive cooling wall treatments that cost under $10 to apply. Thermal mass building techniques that drop indoor temperatures 25 degrees without any mechanical system. Emergency shelter construction methods that outperform $1,200 commercial tents in every documented field test. Water systems, the military classified and then quietly continued using in every forward operating base built after 2003. Fire and food preservation techniques that work when everything modern fails completely. Over 10 full guides. Zero filler. Every technique sourced, documented, and actionable starting today. The link is in the description. But stay right here, because the most important part of this vault is what you are about to learn in the next 4 minutes. Here is the complete practical application, and I want you to treat this section as the most valuable 4 minutes of information you will encounter this summer. Write this down. Go to any hardware store, any home improvement warehouse, or any agricultural supply store. In the ice melt and driveway products section, you will find calcium chloride pellets or flakes sold under brand names like Damp Rid, Driveway Heat, or various store brand ice melt products. Verify the active ingredient is calcium chloride, not sodium chloride, which is ordinary table salt and does not have the same hygroscopic thermal properties. A 2-pound container costs $3 to $5. A 10-pound bag costs $8 to $12. Buy the 10-pound bag, you will use it. Method 1 for immediate room humidity and temperature reduction. Place 2 pounds of calcium chloride pellets into a wide, shallow container, a baking dish, a large bowl, or a purpose-made moisture absorber tray. Set this container in the center of the room you want to cool, not against a wall where air circulation is reduced. The calcium chloride will immediately begin pulling moisture from the surrounding air. Within 45 minutes, you will see liquid beginning to accumulate in the container as the compound absorbs airborne water vapor. Within 2 hours, the felt temperature of the room will drop 10 to 15 degrees in a humid climate and 6 to 10 degrees in a dry climate. Place a second container in the room and the effect compounds. The containers need to be refreshed when they are fully liquefied, typically every 3 to 7 days depending on ambient humidity. Total ongoing cost, $1 to $2 per week per room. Total electricity consumed, 0. Method 2 for wall treatment passive cooling. Mix calcium chloride crystals into standard lime plaster or clay plaster at a ratio of 1 part calcium chloride to 8 parts plaster by dry weight. Apply this mixture to interior wall surfaces in the rooms you want to cool, focusing on the walls that receive the most direct solar exposure from outside. 2 coats, each allowed to dry fully before the next is applied. The treated wall surface will actively absorb both heat and humidity from the room air continuously, as long as the wall is in contact with the interior environment. A homeowner in Tucson, Arizona treated the south and west interior walls of her living room and 2 bedrooms with this mixture at a total material cost of $34. Her interior peak temperatures dropped by 14 degrees compared to the previous summer. Her AC runtime dropped by 60%. Her July electricity bill fell from $310 to $127. She has not modified the walls since the initial application 2 summers ago. They are still performing. Method 3 for the full passive cooling system, combining ancient wisdom with modern understanding. Apply calcium chloride wall treatment to all sun-facing interior walls. Install terracotta moisture absorber vessels in each room filled with calcium chloride pellets and replaced weekly. Apply white reflective lime wash to your roof surface to prevent solar heat gain before it enters the building structure at all. Combine these 3 passive systems, and you replicate at residential scale the exact thermal management approach that kept Roman bathhouses comfortable for thousands of occupants. Through Mediterranean summers 2,000 years ago, total material cost for an average 3-bedroom house, $60 to $90. Total ongoing operating cost, $8 to $12 per month in calcium chloride replacement. Total electricity consumed by the cooling system itself, $0. A retired engineer in Albuquerque, New Mexico, implemented the full 3-method system in his 1,800 square foot Adobe home last summer. As a documented experiment, he ran temperature and humidity sensors in every room throughout June, July, and August. His interior temperatures averaged 68 degrees during the peak afternoon heat, when outdoor temperatures reached 97 degrees. His electricity consumption for the entire summer was 40% lower than the previous summer. His total system investment was $74. He published his sensor data online. The numbers are there for anyone who wants to verify them. Compare that with absolute honesty. New central AC system, $7,000 to $15,000 installed. Monthly summer electricity, $200 to $350. Annual maintenance contract, $250 to $600. Refrigerant recharge every 5 to 8 years, $300 to $700. Full system replacement every 12 to 15 years, back to $15,000. Or $74 in materials, $10 a month in calcium chloride, and the knowledge that Roman engineers, Chinese palace architects, and desert builders across 5 continents figured this out and used it reliably for 2,000 years before your HOA told you it was not an approved method.